Hello, everyone, and I hope that you're doing great. Now, today we're looking at this BGCSE past paper for Combined Science. This is a paper 2 from 2023. Please remember, before you start the examination, write your school number, your candidate number, your surname, and initials. Also, please read through the instructions carefully. And if you have any questions or queries, please clarify them with the examiner before you begin the examination. Also, under normal circumstances, they will provide you with a periodic table, which is great. All right, so let's jump into question number 1 at this time. And question number 1 reads that the diagrams show an animal cell and a plant cell. Some of these structures, I have already labeled them. So we have A is the cell membrane, B is the nucleus, C is the chloroplast, and D is the cell wall. All right, so part A asks us to name parts labeled A and C. And so again, A is the cell membrane and C is a chloroplast. And notice that there are many of the chloroplasts within a plant cell. For B, is to state the functions of B and D. So B is the nucleus and D is the cell wall. And so B controls the activities of the cell, which is the nucleus. And D, which is the cell wall, protects the cell and maintain the shape as well. All right, so protection and maintaining shape. All right, for part 2, is to name the thick fluid that fills the inside of the cell, and that is the cytoplasm. All right, for part C, is the diagram shows different levels of organization of an organism X and Y are the missing parts of the diagram, and so we say identify the missing levels X and Y. And so here we have X and Y here. All right, and so X is the tissue because tissues come after cells. So notice that. All right, so you have cells and tissues. All right, and then tissues will form organs, and then organs will form the organ system, and then we have the organism. So X is the tissue, and Y is the organ system or system, and you will be okay. All right, for part 2, it's a diagram shows the leaf, which is an organ in a plant. It's that the leaf produces food for the plant by the process of photosynthesis. Write the word equation for photosynthesis, and the word equation is water plus carbon dioxide. Actually, you could have carbon dioxide plus water, doesn't matter, once they are the reactant. So water combined with carbon dioxide in the presence of sunlight, light will absorb by chlorophyll, and then we have glucose and oxygen being the products. All right, oxygen is the byproduct or what they call the waste product. All right, so glucose is the main product. So that's the word equation. And please practice also the balanced chemical equation for photosynthesis. It is very important for you to practice that as well. For part 3 is to identify another organ in the plant. And so we have many different types of organs. And so we have stems, roots, flower, and fruit. So those are organs of plants. All right. So any of those will be correct. So question number 2 is the diagram shows the structure of an atom, of an element. All right. And even by the statement, just to make a note here that atoms make up element. All right. So an element is made up of the same kind of atoms. All right. Just to make mention of that one. All right. So for part A, is that the key shows the 3 subatomic particles found in the atom. And so we have electrons, notice the little line through it. All right, we have protons, which is unshaded, and then the neutrons, they are shaded. All right, so you can look at the diagram, you see the electrons on the shells, the protons are the unshaded one, and then the neutrons are the shaded one. Now the question here asks, now we said identify the particles that has the smallest relative mass, and that is the electrons. And I just to make a note right here that electrons, they have 0 mass, so it's 0 grams. All right, they do have a mass, but it's very small to use in calculation. So we just say there's no mass for electrons. Neutrally charged. So once it's neutral charge or neutrally charged, that is the neutron. All right, and for B now, we say the overall charge of an atom is 0. Explain why the charge of an atom is 0. And to earn the 3 marks, 1, we can just mention that there are equal number of protons and electrons. That's very important to mention that. This means that the number of positive particles equal to the number of negative particles, or the number of positive charges equal to the number of negative charges. Hence, The positive and negative charges cancel out each other, and so therefore the overall charge is 0. All right, for part C1, it's a state the atomic number of the atom in the diagram, and the atomic number is 3. How do we know that? Because there are 3 protons. Because protons and electrons are equal, and protons is also equal to the atomic number. All right, so atomic number, proton, and electrons are all equal. All right, next part of the question now, that is C2, is to determine the atomic mass of the atom in the diagram. Give a reason for your answer. And the mass here is 7. I'll go back to the diagram to show you why it's 7. Because we have 3 protons and 4 neutrons. So add up the protons and neutrons, we get our mass, that is 7. So again, the reason is mass is equal to protons plus neutrons. Therefore, mass is equal to 3 plus 4 equals to 7. All right, so the mass equals to 7. The last part of the question here is using the periodic table, name the element in the diagram. And so once you know your elements, atomic number, you look for the atomic number first and foremost. So the atomic number is 3. All right. And so I made a mistake, right? This is the third one. So the atomic number is 3. So there's a third element. All right. And so this is lithium. I had nitrogen there. Yeah, so this is lithium, not nitrogen. Let me just change that real quick. So this will be lithium. Nitrogen will be 7 element, which is not the correct answer. So this is lithium. All right, lithium. All right, let me delete that. All right, so lithium is the correct answer right there. That's the third element. Proton number is 3. All right, and proton number is the same thing as the atomic number. All right, 7 is the mass number. So that was my mistake there. All right. Question number 3 is to define the term energy, and energy is the ability to do work. All right, or it is a capacity in which work can be done or work is done. All right, so that's the definition for energy. Now for part 2 of A is to name the principal source of energy for biological system, and that is the sun or light energy. All right, because why? Because the sun or light energy is required to start any food chain or food web. All right, so producer, especially those that photosynthesize, they will use light or the sunlight to produce the first form of energy. So light is converted to chemical energy in the form of glucose and then ATP, of course. All right, part B is that the law of conservation of energy states that energy can never be created or destroyed. It can only be changed from one form to another. It's a use this principle to state 2 ways in which energy is used in your body. And one is for movement of muscles. And another way you can use energy is to transport substances by active transport. Because remember, we have passive transport, which is osmosis and diffusion. And we also have active transport, which energy is required. All right, so those are 2 basic reasons or uses of energy in our body. Energy is also used to divide cells, also used for chemical reactions. So there are many ways we use energy in our body: for chemical reactions, to divide cells, all right, to move substances, which is transport that I mentioned here. So there are many different ways. All right. And now part 2 of B is to state 1 way that energy can be lost from your body. And the major way that energy is lost from your body is through heat. All right. That's one of the major ways. All right. And then part 3 is stated that suggest reason why a wind-up toy slows down and eventually stops. So once you wind a toy up, I just want to kind of understand that when you're doing the turning, those are toy that you have like a knob and you spin, and you let it go and it start to run. You're applying kinetic energy first by the turning and that winding. All right, you get the kinetic energy, and that converted now into potential energy that is in the spring. So you have a spring inside, there's a spring potential energy inside, and then that convert to kinetic energy again. And of course, you're going to hear some noise, so that means also sound. So in terms of what is happening here, why this wind-up toy slows down eventually is simple because the energy is totally converted. Because once energy is lost to something else, whether by kinetic energy, friction, whatever it is, it's going to slow down. And a point to note is energy is lost in the form of heat as well, sound. All right, those are the ways that that energy is lost. All right, and energy loss to overcome friction as well. All right, because the car or a toy car is moving on a surface or on the floor, so definitely. All right, and so for part C, is that the image shows a man using a leaf blower to move some leaves. It said the leaf blower is powered by an electric motor connected to a battery. It said energy transfers takes place when the leaf blower is being used. It's a complete each sentence to show how energy is transferred through the leaf blower. And so for one, it said the battery stores, and that is storing chemical energy. Chemical energy is in the battery. And it's energy which is transferred to into electrical energy, definitely. So chemical into electrical. And then for two now, it's the electrical motor transfers electrical energy usefully into kinetic energy. All right, because movement will take place in the motor for sure. And then the motor now loses energy in the form of sound and heat. All right, or heat. You can put any one of those and you'll be correct, because the motor is making noise, that's sound energy, and heat is given off as well as heat. All right? All right, and that ends that question. Now, question number 4 is the diagram shows the endocrine system. All right, now I have already labeled these for you. We have the adrenal gland. On top of the kidneys, we have the pancreas, we have the ovary, and then we have the testis here. All right, so they're showing you both male and female together. All right, so for part A, so define the term hormone, and hormones, they are chemicals that are produced in one organ but have their effect or effects in another organ. All right, so in other words, hormones pretty much will trigger response in the organism or in the body. All right, so there are chemicals that trigger a reaction or effect in the body. For part B, is a name one hormone that is secreted by organ labeled P in the diagram, and organ P again is the adrenal gland. So therefore, you will produce adrenaline. All right, and it says state 2 effects of the hormone secreted by P has on the body. And once you produce adrenaline, what you're going to do, you get your pupil dilating, your heart will beat faster, so you have increased heartbeat. You also will have faster breathing. And you breathe faster with increased heartbeat to push more blood and glucose to your cells, so you get more energy, and so you have a super fast reaction or a greater reaction than normal. That's why when you're in trouble sometimes, you may jump a wall without even knowing, or do things that you don't normally do, because you have that burst of energy. All right, for part C and C1, it's a name one hormone that is secreted by organ labeled Q in the diagram. And organ Q, just to go back to that is the pancreas. And pancreas produces typically two hormones, insulin and glucagon. All right, and it said name organ Q, that is the pancreas. And just to make mention here that insulin will decrease the amount of glucose in the blood by converting glucose into glycogen. And glucagon now will do the opposite by converting stored glycogen back into glucose whenever the body is short of glucose, all right, or need a quick supply of glucose for energy production. Now for part D, it said the concentration of glucose in the blood of two persons, A and B, is measured every half an hour. It's a 1 hour after the start, both persons drink a solution containing glucose. The graph shows the result. And so we have two lines here. We have person A, which is the top line, and person B is at the bottom line. And we have the concentration of glucose on the y-axis. And then we have time in hours, which is on our x-axis. It's a use the graph to calculate the maximum increase in blood glucose concentration for person B after drinking the glucose drink. Show working. So I labeled, well, I like actually. I like the start right here, and I like the end, which is the maximum. So the difference there will be the maximum minus the start. Now, the thing is this, if you notice that there are 10 lines between the numbers, and so each line will be 1. All right? because there are 10 lines. So right here we have 88, and the maximum here will be 99. All right, so therefore we say 88 from 99 give us 11. All right, so that is 11 milligrams per 100 centimeters cube, and that's a difference right there. All right, or the maximum increase. All right, so last part of this question is a doctor suggests that patients A has diabetes. Is to give one piece of evidence from the graph to support this suggestion. And if you look at the graph for person A, notice is way above person B. All right, if you notice that. All right, so use the graph to calculate. No, sorry, but last year here I'm at right. So the last part here said no. It said give one piece of evidence from the graph to support that patient A has diabetes, and this simple factor is that the glucose level in the blood is much higher. All right, and normally if you have a high glucose content in the blood, that means you're diabetic. All right, and also a next point you can use to support this evidence is that the maximum value is 40 millimeters per 100 centimeter cube higher than the patient B. All right, so it's way, way higher. All right. Next question here. It said the diagrams illustrate bonding between the atoms in substances A and B. Now, substance A, we have sodium ion and we have chloride ion. And then substance B, we have OCO, which is CO2. So this is carbon dioxide. All right, this is sodium chloride going to form over here, which is substance A. And substance B will be carbon dioxide. All right. So it said name the type of bond illustrated in substance A and B. So substance A is ionic, and well, they asked for a reason on the bottom, so I'll tell that a little later. And then for B, it is covalent. You know, it's to give reasons for your answer A1. And so substance A is ionic, simple because it involves charged ions, which is sodium ion and chloride ion, and also involves a metal and a non-metal. All right, so if you notice here that sodium is a metal, all right, and chlorine is a non-metal. All right, just delete. All right, anyway, I'm not going to type it back. It's simple, just to remember what is there. That sodium is a metal and chlorine is a non-metal, so it involves a metal and a non-metal. All right, for substance B now, it is covalent because electrons are shared. So notice electrons are shared between two atoms. All right, and not only that, it involves only non-metals because oxygen is a non-metal and carbon is also a non-metal. So therefore, covalent bond involves non-metals only. For part B, so suggest the state of matter of substance B. And substance B, again, is carbon dioxide, carbon with two oxygen, carbon dioxide, and carbon dioxide is a gas. So therefore, the state of matter is gaseous. All right, part C is to explain how the bond is formed between sodium plus, which is sodium ion, and Cl minus, which is chloride or chloride ion. All right, ions in diagram A. So what's going to happen here is that an electron is transferred from sodium to chlorine. That's what happened in the bonding process, right? An electron is being transferred from sodium to chlorine. And we know this because metals lose electrons, non-metals gain electrons, all right? And so sodium now is Na, so Na loses an electron and become a positive charge, while the chlorine will gain an electron and become negatively charged. All right, so it becomes a negatively charged ion. All right, and say now the oppositely charged particles attract each other. So once the sodium atom actually loses electrons, or one single electron, it becomes positive. The chlorine gain that one electron and becomes negative. And so positive and negative will attract. And so that's how they bond together. All right, part D. It said hydrogen is a non-metallic element found in group 1. As a matter of fact, this is the only non-metallic substance or atom that is found in group 1. All right, and the reason why it is in group 1 because it has one valence electron. But it's also in group 7 because it needs one more electron to become a full stable shell. All right, so therefore you can place it in group 1 or group 7. That's why most periodic table place it by itself in the middle, but it is a non-metallic substance. All right. Now, chlorine is a non-metallic element as well. All right, found in group 7 of the periodic table. It said hydrogen reacts with chlorine to form hydrogen chloride, otherwise called hydrochloric acid. All right, and it's a construct a dot and cross diagram to show the bonding in hydrogen chloride molecule using only the outer electrons. So again, hydrogen has 1 electron. I put hydrogen in blue. Chlorine has 7. All right, again, it's in group 7, so it has 7 valence electrons. Hydrogen is in group 1, as they suggest right here, so it has 1 valence electron. So again, each of them require 1 more to become a full shell. Hydrogen only requires 1, not 7. Why it requires 1? Because it's the first shell. The first shell can only hold a maximum of 2 electrons, all right? So therefore, only 1 more is required. So therefore, chlorine will give up 1 in the sharing. Hydrogen give up its only 1 in the sharing. And so around the blue shell, you notice that there are 2 electrons. And around the red shell, you notice that they are a total of 8 electrons. All right, so that's how we have hydrogen chloride or hydrochloric acid. All right, part 2, which is the final part of this, is to explain how the hydrogen and chlorine atoms are bonded together in the hydrogen chloride molecules. And simply what happened here is that electrons are shared between the atoms. Shared, that's very important, shared. Ionic bonding is transfer, covalent is sharing of electrons. All right, so the sharing of electrons result in a full valence shell of well, it's supposed to be of each of the atom, right? So let's take out the word for right here. I'm not going to change it to may disappear everything, or everything may disappear. All right, so yes. So the valence shell for each atom will become full. Question number 6 is that some students are investigating waves. It said a student dropped a pebble in a ripple tank of water to produce water waves. A digital recording of the waves is made, and it said the diagram shows the waves over a distance of 18 millimeters. All right, so from start to finish, that's 18 millimeters right there. And notice that the height of a crest right here is 4 millimeters. All right, and just a point to note, if the crest is 4 millimeters high, then the trough is also 4 millimeters depth as well. All right, so for part A, it's a stated number of wavelengths shown in the diagram. A number of wavelengths, so I'm going to show you what a wavelength is. A wavelength is the distance between 2 consecutive points or 2 equal points on a wave. So if I start from right here and I stop right here, that's a wavelength. And if I start from where I just marked to right here, that's another wavelength. And if I start from there to here again, that's another wavelength. So there are 3 total wavelengths in this wave, okay? 3 of them. All right, and so just go down a little bit. Yeah, so number of wavelengths will be 3. Is a calculate the amplitude of this wave. And so the amplitude, all right, just highlight this again. Amplitude, let me highlight this. Let me just put this in a different color. So the amplitude, notice the 4 millimeters start from the bottom right here to the top, okay? So the entire height and depth together of the wave is 4 millimeters. But amplitude is from the broken line, which we call the undisturbed position, to the top of the crest or to the bottom of the trough. So from that line to here, that's the amplitude, or from here to here, that's the amplitude. All right, and so half of 4 is 2. So divide divide 4 by 2, you get the amplitude, all right? Because the entire thing is 4, but only half of it is the amplitude. All right, it's a calculate the wavelength of the wave in millimeters. And if we know the entire distance from here, from start to finish, is 18, and there are 3 wavelengths, so we divide that by 3, 18 by 3 to get our wavelength. All right, and so 18 divided by 3 is 6. All right. Part B, it said the students produce a different wave. It said this wave has a frequency of 1.7 hertz and a wavelength of 8.0 centimeters. It's a calculate the speed of this wave, and again, speed of wave is equal to frequency times wavelength, and we have the frequency, which is 1.7 hertz, and the wavelength here is 8 centimeters. So therefore, the speed is 1.7 times 8, give you 13.6 centimeters per second. All right. Part C is a sound waves or longitudinal waves. Explain how longitudinal waves travel. And first point to note is that longitudinal waves travel in the same direction as the disturbance that caused the wave. All right. And next point you can make right at the particles of the wave are parallel to the direction of the wave. So either or either, you're good to go. All right, for part 2, which is the last part of this question, it says state 2 other properties of sound. And one is that sound travels faster in denser object. So the more dense the object is, you have more vibration can take place. Hence, you have sound wave moving faster. Next point is that the loudness of sound depends on amplitude. All right, so as amplitude increases, the loudness increases as well. And then the pitch depends on the frequency. So the more wave cycle produced per second, you have a higher pitch. All right, and again, the next property of sound waves, that sound waves or sound can travel in a vacuum. Sound require a medium because of the vibration of particles. It require a what? Medium to travel. All right, question number 7, and we're almost there. Is that 2 separate experiments are carried out to prepare a sample of oxygen and carbon dioxide gas. Experiment 1, decomposition of hydrogen peroxide is used to prepare a sample of oxygen gas. The equation for the reaction is hydrogen peroxide, and hydrogen peroxide is H2O2, so you can make a note of that. H2O2, water is H2O, and you get oxygen. So the students now test the gas produced to show that it is oxygen, and so name the test that you use to test for oxygen, and that is called a glowing splint test. For positive result, the splint will be relit or reignite. All right, because the way you do this is light a piece of splint or piece of stick, blow it out, but it's still going to have that thing on it, or the glow or that reddish burning stick will still be there. And once oxygen is present, then you're going to relit or reignite, because oxygen supports combustion. For experiment 2, calcium carbonate and dilute hydrochloric acid is used to prepare a sample of carbon dioxide gas. The equation for the reaction is calcium carbonate plus hydrochloric acid give a calcium chloride, which is a salt, plus water and carbon dioxide. And you should also know that when acid reacts with a carbonate, you will get a salt, water, and carbon dioxide. Now for part B, is a describe the test using lime water that the student used to identify the carbon dioxide collected and state the positive result. And so the description of the test is that the gas, which is carbon dioxide, is passed through or blown through lime water, and then the positive test will indicate that the lime water turns milky to get that white milky coloration in the lime water. All right, and then part C now is a state the percentage composition of oxygen and carbon dioxide in unpolluted air. So in normal air, oxygen will be about 21% and carbon dioxide will be about 0.04 or even 0.03. Okay? All right. And then now, part D suggests a gas that is a common pollutant in air. That is sulfur dioxide, we have methane, we have carbon monoxide, and we also could have nitrogen dioxide as well. All right? Or oxides of nitrogen. Part C is that in an experiment to investigate air and combustion, students use the apparatus setup shown in the diagram. The gas jar placed over the burning candle is filled with air. Observations are made after 3 minutes. So notice we have air on top of the candle, we have a burning candle, we have a trough, and we have the water. Now, it suggests one observation you expect the student to make after 3 minutes. Give a reason for your answer. And a logical observation that you're going to see right here is that the candle will stop burning. And the reason for that because oxygen in the air will be used up. And again, because of the burning, you will have more carbon dioxide compared to oxygen. So the ratio of carbon dioxide will be much higher than oxygen. And remember, oxygen supports combustion and carbon dioxide will suppress or extinguish combustion. All right. Part 2. Identify the gas in the gas jar that increases in percentage by volume after 3 minutes, and that is carbon dioxide. Because when you burn anything, combustion produces carbon dioxide. All right, so you have more carbon dioxide built up in the air after 3 minutes. Part F is the volume of air in the gas jar at the start and end of the experiment is shown in the table. So the volume when you start is 200, and the volume of gas after or the end is 158. And so change in volume right here, it is 42. So they ask us to calculate the change in volume, and that is 200 minus 158. That gives us 42. All right. So 42 is the correct answer. Last question. So the diagram shows 2 iron nails hanging from a bar magnet. It's the iron nails, which were unmagnetized, are now magnetized. It's a name the type of magnetism shown when nails like those in the diagram attract other nails, and that is induction, because we have an induced magnetism from one nail into the other. All right. Please notice, well, not notice, but please know the different types of methods that you can use to magnetize, such as stroking, all right, induction, and electrical and electromagnet. All right, so please know those. All right, it's good for you to know those. It's a name a material that is considered to be a natural magnet, and it is called lodestone. Notice how the load is spelled. This Lode, lodestone. And for part 3, it's a state 3 ways a permanent magnet can lose its magnetism, and one is by applying a lot of heat, high heat, not just any heat, but high heat really. Hammering can also cause that, which is beating the magnet, and dropping the magnet quite often can also cause it to lose its magnetism as well. All right, part B is magnets are used in everyday life. So the diagram shows a magnetic closure box when open and shut. So it's the box stays shut when it is closed due to the forces between the 2 small magnets. All right, and it said the magnets in the magnetic closure box must not have 2 north-facing poles. All right, and it's explained why the box must not have 2 north-facing poles, and this is simply because like poles repel, and if you have 2 north poles, then they will repel and force the box to open. All right, so they must attract to keep the box closed. Part C is magnets can also be made using electricity and a metal core wrapped with a coil of wire. All right, and there's a state what happens when both ends of the wire are attached to the battery, and once those wire ends are attached to the battery, current will pass through and the nail will become magnetized. So the answer here that the nail will become magnetized. All right, normally use a soft iron core, which is like a nail you could use as well. Last part is to state 2 ways the strength of this magnet can be increased, and one is to increase current by adding more batteries, and that batteries must be added in series to increase the current. All right, and also you could increase the number of turns. So there are 2 ways to increase electromagnet. The strength of electromagnet is 1 to increase the current, and 2 is to increase the number of turns. All right, so this is the end of this review. Thank you for being here. Thank you for watching. And I wish you great luck on your examination. Take care, and I will see you soon.